3.3a are properties of logarithmic functions, and today we're going to talk about expanding, and then we'll do the condensing part tomorrow. A quick recall of properties of exponents. If the bases are the same and there's multiplication, we take and we add the exponents together. So this would be x to the 4 plus 6 or x to the 10th power. And if we have like bases in which we have division, we then subtract. So we would get x to the 10 minus 3 or x to the 7th. Now, the reason I'm telling you that is because the rules are very similar when we're doing logarithmic functions. When the bases are the same, keep in mind the base is no longer that big base, the base is that small number. When the bases are the same with logarithmic functions and you're multiplying, you're going to do the same as you did with properties of exponents. You're going to add the exponents together. And if the bases are the same and you're dividing, then you're going to subtract the exponents together. And here are your expanding and condensing rules. So again, we are going to expand today. So you're going to start with this and you're going to move to this. So you begin with one term of log and you are going to have multiple terms of log depending upon how many terms follow this right here. Here we have two terms, the a and the c. Therefore, we wrote log of base b twice, once for the a, once for the c. And we put a plus between them because we had multiplication right here, and we know that multiplication and addition go together. When we're doing the quotient, again, we have only one log, but we're expanding it to multiple terms, and we're doing two terms because we have a and c. So we write log base b twice, and the first one gets the a, the second one gets the c. And because we have division and subtraction go together, we have subtraction between those two. So take a look at these problems here. We have log of base 2. We have this condensed down into one term of log, but we are going to expand it into multiple terms of logs. We are going to expand it twice because we have an x and we have a y. So in other words, we will write log of base 2 two times. The first one gets the x because the x is first. The second one gets the y because the y is second. And because multiplication is right here and multiplication and addition go together, we will put a plus sign between them. If you look at the next one, we have log base 4. It is condensed down to one term, but we are going to make it into two terms because we have an x and a y, two terms that follow. So I'm going to write log of base 4 twice. The first one gets the first term, which is the x. The second one gets the second term, which is the y. And this time, because we have division between them, we are going to put a subtraction sign. Now the next one is different in two ways. First of all, we don't see the base right here. Remember, if there's not a base, we can assume it's base 10, log base 10. Now, just like they didn't write it, we don't have to write it. But this time we are going to write the term log 3 times because we have an a, a b, and a c. So I'm going to write log with base 10, or in this case just a log, 3 different times. The first one gets the first term, which is the a, the next one gets the b, and the last one gets the c. Now, we have multiple terms here that are being multiplied and divided together. Any time you have a fraction right here with more than just one term on the top and one term on the bottom, anytime you have anything on the top, it gets a plus sign, and anything on the bottom gets a minus sign, and that goes before you see the variable. So the a is on top. Well, the first one always starts at positive, obviously. Between the a and the b, we have multiplication. The b is on the top, so before the b, we will put a plus sign. The c is on the bottom, so before the c, we will put a minus sign. And that's what that looks like with 3 terms. The a was also on the top, so before the a, it's a plus sign. We don't need to really worry about that. Now the next one is different because it has this number, and when you have a number, you have to simplify. So I'm going to write my log base 5 twice because I have 2 terms that follow. So I have this. The first one gets a 25, the second one gets an x, and because I have division right there, the x is on the bottom, it gets a subtraction. Now, if you wrote your answer like this on the test, you would lose a half of a point, because what you did not do, or what I did not do, is I did not simplify this. Anytime you have all numbers, you need to simplify. And remember, when we did this, I'm going to just do a little off to the side right here. When we solved this before, we put a variable right there and we said, oh, 5 to this power is equal to 25. 5 to the x power equals 25. Oh, well, that is the same as if I square that. So that is a 2. So I'm going to replace this whole thing with a 2. So what this is equal to is 2 minus log of x, and the base is 5. And that would be the correct answer for your test to get full points. All right, the next rule we need to understand is called the power rule. And the power rule is anytime you have a power on something, you can punch it down and you can pull it in the front and make it multiplication. So that's how we go from a power to getting rid of the power. And that is important because you cannot leave powers in the final answer when you are expanding. So the first thing you'd want to do before you expand or condense anything is you would take any of the powers you have and you would punch them down and pull them in the front. So this would become 2 times the log of 3, or log of x with base 3. That's an example of how the power rule works. Now, let's talk about these two problems. These are important because you can also not have a radical in your final answer. So if you have a radical, you have to write it as a power and then punch it down using that power rule. So we know that this is the same as x to the first power, and a square root is like a 2 here. So how I would write that as a rational exponent is log of x to the 1/2 power. Now I can take and punch down this power right here to make it 1/2 times log of x. And that right there is my correct answer. Now, in looking at the next one, if you have parentheses and it goes to the a power, remember everything inside has to go to that power. So this is going to be 8 to the 4th power and x to the 4th power. Or in other words, I'm going to put the log with the base in front of it right here. Now, 8 to the 4th power is 64 times 64. It's 4,096. X to the 4th. There you go. There you have something. There you have that right there. Okay, so let's do a few problems with expanding when we have a power. So in this first problem, we need to get rid of those parentheses first. Parentheses with powers means everything goes to that power. So this is really the same as log of x squared divided by y squared with base 6. Now we can take and we can expand this. So what I have here is I have 2 terms, this term and this term, that follow my log. So I'm going to write log with base 6 twice. The first one gets the x squared. The second one gets the y squared. And because it's division, I have subtraction that goes between there. Now you can't leave your answer like this. You have to take and punch these powers down. This 2 has to come out in the front, and this 2 has to come out in the front. And it only goes out in front of whatever, in front of the log. So this is the same as 2 log of x with base 6 minus 2 log of y of base 6. That's the answer right there. Now the other thing you could have done, you could have punched this power down to begin with down here. So you could have made this 2 times the quantity of log of x over y with base 6. So you could do it like this, then you could condense it, and then you could redistribute. Well, I shouldn't do that. That makes it look like it's wrong. But then you would have the 2 out in front here, and you could redistribute that to your logs to get your answer. Okay, looking at the next one, we have to rewrite this again as y to the 1/2 power before we can go ahead and expand this out, because we can't have radicals in our answer, and if you leave a radical, you're going to get it wrong on the test. So now I have 2 terms, so I'm going to write log with base 2 twice. The first one gets the x, The second one gets the y to the 1/2. This is multiplication, so it'll be addition. And I'm almost done. I can't leave that power. I have to punch it down and pull it in the front. And that is my answer. So log of x with base 2 plus 1/2 log of y with base 2, right there. Okay, we're getting to a few more complicated ones. So let's take a look at this, and then I'll give you an opportunity to try some as well. So here we have log, the base is 10, it's not listed, we don't have to list it. And we have to list log 1, 2, 3, 4 times, one for each term. Now there's a lot going on with this because the first one is log that gets a 10, and that has all numbers, so this one right here is going to have to be simplified. We'll do that in a minute. The next one, I can't write that as log of square root of x. The square root of x is equal to x to the 1/2, so this is going to have to be x to the 1/2 power. I will have to use power rule in that and punch that down, but I'll do that in a minute. The next one gets the y, the last one gets the z squared, which will also have to be punched down. Now let me get my signs in here really quick. Everything on the top will get a plus sign before it. So this gets a plus sign before the x because that's multiplication and it's on the top. This is on the y's on the bottom, the z's on the bottom. That's going to get a minus, and that's going to get a minus. Now let's simplify this further. Log of 10. Well, log of 10 is like log of base 10, and we know essentially that log of 10 and the base 10 are going to simplify away and give us 1. We could also write this as 10 to what power gives us 10, and clearly it is a 1. So this will be replaced with a 1. The 1/2, the power, is going to be punched down. Nothing happens with the third term, and the 2 will be punched down, and this right here is our answer. Now you can go ahead and pause the video and try the next one. Once you rewrite that radical, you're going to get it as x to the 1/3, and you can see what the answer would be right there, and hopefully you got that correct. And here's a few more examples in which you can try. I'll do the first one with you, and then you can try the second one. So here we have log base 2. I'm going to write that 1, 2, 3, 4 times. And the first one gets the 100. The second one gets the x to the 3rd. The next is the y. The next is not square root of z, it's z to the 1/2. We have to rewrite that. Now we have, addition between all of these because it's all multiplication. That makes it easy. The only other thing we have to do is punch down both of those powers right there and then simplify this if we can. And this is 2 to some power that equals 100. This does not give us a radical. So what we're going to, it gives us an irrational number. It's not an integer. So what we want to do is we want to use our calculator to determine this. So what you're going to do is this. You're going to hit the math button. And then what you're going to do is you're going to go down to A, which says log base. And when you hit that button, it's going to allow you to change the base. And then you can change the base, and you can make this log base 2 and make that a 100. And when you do that, what you get is 6.64. So I'll replace that with 6.64. Now, if you're still struggling with that, and you can't find that, please make sure you ask me on the Google Meet so that you can get that cleared up. And you can try the last problem on your own. And you should have this for your final answer. And just make note that you have a subtraction here and a subtraction here because these are both on the bottom. Make sure you write that to the 1/3 power. And I see I made a mistake there. I wrote that as a 1/2. It's a 1/3, so it's a 1/3 power. And make sure you evaluate this, and now you can use your calculator using your change of base function right here. If your calculator does not have that, I'll show you in a minute here on how you can find that with a regular calculator. Really quick, what is natural log? We've talked about this. ln is natural log. It is the natural base. It is just a log with base e. So log with base e is what a natural log is. And the reason you need to understand that is because you're going to have to condense, or you're going to have to expand things. This is condense, but you're going to have to expand things with natural logs, and it's the same thing. This is just a log with base e. So I could write log with base e 2 different times, one for x, one for y, okay? But I can also write it as natural log, which is shorter. So in doing that, this is how my first one would be, written like that. So the rules stay the same, you just write ln. Now the difference in that is, if you take a look at number 2, if we do ln of e to the third minus ln of 7, that's what that would be. This right here we can simplify, and this is equal to 3. So this is our answer. Now, how I know that is because the natural log and the e right here simplify away and leave that with an answer. You can also plug this in your calculator. You could go and hit the natural log button, which is right under log, and then you could hit the e to the x button, which is hitting second natural log. So the same button, you just hit the second first. And then when you have, you replace that with a 3, and when you hit equals, that would give you the answer of 3. Now, if you want to try the next one, you can pause the video, otherwise keep it plain. Now that's as far as you can simplify that one, because we don't want a decimal for this, so you'll just leave it like that. And this I got from my calculator, and that's in the wrong spot. Okay, you are going to start your worksheet 3.3. You're only going to do the expanding, the front side. Do not submit it into Schoology until you've completed the back side, which is with tomorrow's video and lesson. Have a great day. Bye.